now that we've done the experiment and we've got this extra example, let's see how we can fill out this worksheet. Okay, so the first question is, what is the orbiting object doing? And then if you're a student, you could ask me a question in the comments like, I kind of think that this is obvious, but I'm not sure. So I actually as a student, I type this in. My answer seems too obvious, but I'm just going to go for it. The orbiting object is going around the sun. That's what an orbit is. So I guess that's what I'm going to say. Okay, what are you as the sun doing? Okay, so when I was spinning that thing around, I definitely have to do the spin. I, as the sun, was actually spinning the object, but also pulling on the string. And that's actually the most important part of this. Like any model, there's limitations. The sun doesn't actually whip it around. All the sun's role is doing is pulling as a gravitational force. From our examples, we could see it's actually the velocity of the orbiting object that keeps it going straight. Okay, is the sun pulling on the planet? How do you know? We've seen it many times. The sun is pulling on the planet. I know because, how do you spell because? A-U-S-E. I know because if I let go of the string, the planet flies away. Let's see, what happens to Earth if you let go of the string? All right, and so this is actually the anti-gravity. You're taking away the gravity of the sun. If I let go of the string, the Earth flies away. I'm just going to expand on this a little bit because there is no force holding it close to the sun. It's always best to explain yourself a little bit further or add a because. Okay, what's next? What happens to the sun if you let go of the string? If I let go of the string, the sun basically stays in the same place. This one's tricky. When I was spinning that thing around my head in the original example, I could actually feel the force. So I'm going to actually say something like that. The sun doesn't have as much force pulling on it without the Earth attached by the string. It's kind of a small detail, but it's actually pretty good insight. What happens if you shorten or lengthen the string? Okay, if I shorten the string, the orbit gets shorter and the Earth object actually moves faster. And if I lengthen the string, the orbit gets longer and the Earth object moves slower. What happens if you increase the mass of the orbiting object? Okay, so here I could feel it. I could feel the pull in my body when I was spinning it over my head. And we could also see that in the baseball example, increasing mass really pulled on that central mass and it tipped it over. if I increase the mass of the orbiting object, see, how would I put this? If I increase the mass of the orbiting object, the sun actually gets pulled harder. I could feel this pull in my body, and also I could see it in the baseball example when the tee kept getting tipped over. Okay, I think that's pretty good. What does each word of this simulation, or each part of this simulation, represent? So the student represents the Earth, the object represents, double click just to fill in the space, the object, oh, I got it wrong. The student represents the sun, the student was in the center. Object represents the Earth, and the string represents gravity. Now I typed these answers in already. Let's see what it says. When I let go of the, what evidence do you have that the sun's gravity actually pulled on the Earth? When I let go of the string, the Earth flew away from me. So this must mean the string was actually pulling the shoe or the baseball back towards me, or in the case of the baseball, back towards that central mass. All right, what evidence do you have that the Earth actually pulled on the sun? So this is kind of similar to before. I could actually feel the pull from the Earth on my body, in my arms, in my abs and my arms. My arm was getting pulled and it was hard for me to keep spinning in a circle. I had to fight against it. I'm going to add the baseball thing. In the baseball example, the tee kept getting tipped over, which must have happened by getting pulled by the Earth. Okay. All right, so now I've got to draw a picture to represent my new gravity model. Okay, so in my previous gravity model, I had I used the arrow to show gravity and an orbit. This model I've got to include some of my new learning and my new thinking. So I'm just going to use the same basic layout. I've got my circle. Fortunately, my marker bled through, so I've got a nice pattern to go by. This will still be my sun and my planet, which we know is Earth. Now last time I did an arrow going from here to here, and I think I'm still going to do that. But this time I somehow need to show that this arrow is actually it's coming from the sun. So I'm going to try to just make it more connected to the sun, I guess. And then I'm going to so this is going to be gravity. Oh, I'm going to do it from the sun, like an S like that. And then I remember that the sun, or the central object, actually got pulled too, so that was getting pulled by the planet. So I'm also going to put a smaller arrow and this is the gravity from the planet. I'm trying to show that it's smaller. Alright, so then I'm going to do something with the orbit too. So I just had this orbit. And so this actually also is something important about the planet having its own kind of velocity. So I'm going to call this velocity. And then it's a combination, maybe I can show this over here. A combination of those two results in a different path. Gravity here, velocity here, and maybe I'll say that this is the orbit. Hey, it's just me showing my thinking and kind of drawing as I think out loud and trying to take what's in my brain about this and put it onto paper. Maybe it'll help me understand it more. Maybe it'll give me some new insights into it. Okay, I think I'm going to color this in and I'll upload it. Okay, final stretch. Now I just need to insert my picture into here and then type a little explanation. So I'm going to choose Insert, Image, Camera. I just need to hold this up to the camera, try to keep it flat, try to get everything in there. Alright, that does it. Press Insert. Oops, I put it in the wrong spot. Let's see if it works for me just to drag it into here. Yep, kind of. Ooh, I'm going to try again. First I'll delete this. Now I've got my cursor in there. Insert, Image, Camera, and my picture is actually already there, so I'm going to insert that. Okay. Now, even though, you know, let's just get rid of me, double click, and crop that down, and crop this side. How does that look? Yeah, that's pretty good. That shows what I want to show. Now I just need to type in my explanation. In my new model, I added arrows showing gravity from both the Sun and Earth. I also tried to show how the velocity of the Earth is needed to create the circular path of the orbit. Okay, I think that's it. Now I've got a couple more activities to do in this worksheet, so I'm not going to turn it in yet, but I'm well on my way.